Hi, my name is Abby, and today we'll be going over negative inducible control of the lac operon. Here's the operon. It's considered negative inducible because there is a regulatory protein that prevents transcription from occurring across the operon. Going across the strand, here you see the lac I operon gene. This codes for the repressor. It's the regulator gene. Here is the promoter gene, or the lac P gene, where RNA polymerase binds to start transcription of the proteins coded down the line. Lac Z, lac Y, and lac A. Lac Z codes for beta-galactosidase, lac Y codes for permease, and then lac A codes for trans-acetylase. All of these are considered structural genes. Because it is negative inducible, the system normally is off and no transcription occurs. Right here is the activator regulator, the active regulator, or repressor that bonds to the lac O site right here. The lac O site is part of the lac P and lac Z site. When lactose is absent, there is nothing to repress the repressor, so it attaches right to the lac O site. This stops RNA polymerase from binding, and there is no transcription from the proteins. You'll also see that in a normal operating operon, the genotype of all the genes have plus signs by them, meaning that they are wild-type genes and there are no mutations. Right here is also a normal lac operon, but with lactose present. With lactose present, the operon is induced, meaning that there are proteins being transcribed. When the molecule allolactase is bound to the repressor molecule right here, it represses the repressor and allows RNA polymerase to bind to the lac O gene, transcribing all of the other enzymes and creating proteins. These proteins then help lactose, specifically beta-galactosidase, to turn into allolactase and then bind again to the regulator protein. Here again is the normal genotype for a lac operon. As stated before, the positive sign means it's a wild-type gene and is inherently normal, but there are cases where the genes are not normal. One example being the OC gene. The C stands for constitutive operator. This means that the operator cannot bind to the receptor. And as opposite the plus sign, the negative sign means that the enzymes are defective. In this specific diploid genotype, we can see that the I has a negative sign, meaning that the repressor it creates is mutated and it will not bind to the O site. In the next line of the genotype, there is a normal working I gene. So it will create repressors that can bind to both strands. We see in the second strand, though, the OC gene will stop any and all bonding of the repressor. Overall, one strand will be transcribed normally, except for the lac Y gene, due to it having a negative sign up, meaning that only beta-galactosidase will be produced.